So in this question here, we've got the bottles in a factory are made and they are on average 25 centimetres tall. And the standard deviation is 2.5 millimetres. So the variance of that would be 2.5 squared millimetres, which is 6.25 millimetres. Now we want to know what is the probability of 4 bottles being chosen at random that are less than 249 millimetres. Now we're assuming that this is a situation where they want to check that the bottles are being produced nice and consistently to try and improve sales. So they don't want to see too many changes in the sizes so customers know what they're getting. So the probability that 4 bottles chosen at random are less than 249 millimetres, and we're given an average height of the bottles and a standard deviation of that height of 2.5 millimetres. So we can assume that these bottles, the various measurements of this taken from a large sample, follow a normal distribution. So the normal distribution, if we call these B for bottles, B is normally distributed with mu and variance. So mu and sigma squared, mean and variance. So in this case here, we'll have our mean of 25 centimetres, but the standard deviation is in millimetres. So it makes sense to transform everything into millimetres. So here I would have my mean as 250 millimetres and my standard deviation will be 2.5 millimetres, or my variance will be 6.25 millimetres. So that would be what we've got to do there. Now we want to find out that the bottles are less than 249 millimetres and for 4 bottles chosen at random. So we want the probability that the bottle chosen, so B for the bottle, that's our random variable, is less than 249 following the distribution of this. So we want B, that's the bottle size, normally distributed with 250, and we've got 2.5 squared. So instead of writing 6.25, I'm going to write 2.5 squared. Okay, so here we can use our calculator to try and work out our values, where we can type in our mu as 250, our sigma as 2.5, and our x value as 249. So this one here. So what that would give us out, if we type that into our calculator, that would give us 0.3446, so approximately, depending on what calculator you've got and how much level of decimal points you want to calculate it by. So 0.3446, but that would give us the probability of 1 bottle chosen at random from a sample. But we want the probability that there's 4 bottles chosen at random that are less than 249. So what we'd have to do now, we'd have to raise this to the power of 4. So the probability our bottles are less than 249 for 4 of them. So to the power of 4 equals 0.3446 to the power of 4. And if you do that in your calculator, you get approximately 0.014, which comes out at approximately 1.4%. So we can see here to get 4 on the trot, or 4 from the sample, sorry, is 1.4%, whereas to just get 1 alone is 34.46%. So a probability to get 4 bottles chosen random less than 249 millimetres, 1.4%. And that would be the answer to our question. Okay.